Bienvenidos, Hushamdi, and welcome to this HUD 8 networking techtorial on Cisco's Enterprise Networking Security and Automation course. It's part of the CCNAv7 curriculum that was just released by Netacad. In this tutorial, we're going to be focusing on Packet Tracer Activity 2.5.3, where we're going to be talking about propagating a default route into OSPFv2. So, what can you plan on learning in this techtorial? Well, we're going to talk about the default information originate command. We're also going to talk about one of the options with that command, which is the always keyword. We're going to see what that means. We're going to talk about the default metric value for a default route that has been originated in OSPF. I'm also going to show you how to change that metric value, talk about why you might want to change the metric value, and we'll look at the metric type. Because as you know, there are different metrics for different LSA types. And so we'll talk about the OE2 and the OE1. And let's go ahead and dive in here and take a look at the activity. So as you can see, we have the addressing table over here on the right, along with our objectives and the steps we're going to be following. And so let's go ahead and dive in here on part 1. Now, part 1 wants us to test connectivity first. So let's go ahead and pull PC1 up and jump onto the desktop here and get a command prompt up. And it wants us to ping that Internet Web Server 64.100.1.2. And so we want to check and see, do we have connectivity? And the answer is, from here, we do not. And actually, let me make these PCs a little bit larger here to give us a little more room. So PC1 cannot get there. What about PC2? Can PC2 reach the web server? So let's get onto the command line prompt and let's say ping 64.100.1.2, and we're getting this destination host unreachable. I'm going to talk about why we're seeing that here in just a second, but let's go ahead and wrap up here and make sure that we have PC3, and we'll pull the desktop up and we'll say ping 64.100.1.2. Now, again, it's asking us, were any of the pings successful? What message did you receive and which device issued the message? Well, we're getting the destination unreachable, and it's telling me that the destination unreachable message is coming from, at least for for PC3, it's coming from 192.168.1.1. Well, let's go back to the desktop here and take a look at the IP configuration, and we can see that the default gateway for PC3 is actually router 3. And it's going to be that interface, and it should be a gigabit Ethernet interface. If I say show IP interface brief, we can see it's that gigabit Ethernet 00 LAN interface. And so for PC3, and let's change to red here, for PC3, that is the default gateway address. So the traffic on PC3, when we say ping 64.100.1.2, PC3 says, do I have a network for 61.100.1.2? And the answer is going to be no. But PC3 has that default gateway that's set. And so PC3 is going to send that traffic to its default gateway. Now, when the traffic gets here to R3, what's going to happen is router 3 is going to look at that IPv4 header information. And it's going to look at the destination IP address, because that's what routers do. They route traffic, and in this case, they're routing the traffic based off the destination IPv4 address that's in that IPv4 header. So if I was to say show IP route, what we're looking for here is in this routing table on router 3, is there a specific route for the 64.100.1, and I'm assuming it's .0/24, the network and the subnet mask length. So do I have a route to get to that web server? And as you're looking through this table here, we see that we have no specific route. In fact, when we don't have a specific route, the next question should be, do I have a default route? And the answer is no. There is no default route here, and we can see that based off the gateway of last resort is not set. So in other words, the full process that takes place here is we issue the ping command. That ICMP traffic is going to show up here on router 3 with a destination IPv4 address of 64.100.1.2. Router 3 does what a router does. It looks into its routing table and says, do I have a match for the network that this traffic is going to? If the answer is yes, then router 3 will then look for the outgoing interface and forward that traffic along its way. If the answer is no, it would look and see, do I have a default route that I can use? And we clearly see here the answer to that question is also no. And so the result is that router 3 is going to send back to PC3 a destination host unreachable message. And that was the message that we saw when we looked at the ping command here on the PC in the command prompt. Destination host unreachable, who's telling me that? My default gateway is telling me that. Well, let's go back over here to PC1. We see the same thing. It's coming from a different address because the default gateway for PC1 is router 1. If I come onto router 1 and say show IP interface brief, we can see that there is that LAN facing interface. On PC2, the same thing, but it references router 2's gig 00 interface. And so that is the message that you're going to see. This is why you're going to see the message. And if I said show IP route, you can see there's no specific match for that network, and the gateway of last resort is not set. And the same thing will be true here when I say show IP route. The gateway of last resort is not set. So this, and again, the reason I wanted to walk through all three of these is because this should drive home the entire premise of this activity, which is I have a small network, right? Maybe this is in an, oops, sorry, I want to pull that back there. So I have a small network, right? And maybe this is in an office, and these devices are all connected up and they're all on their individual LANs. And we have a single path out of our network. And we'll just say, you know, hey, this is company A. And we have a single connection to our service provider. Here is the network on which we're connected to that service provider. And all of my hosts in this network need to be able to get out to the internet, because consider the alternative scenario. And the alternative scenario is that you have to put a route on every single router here so that the traffic so that the router knows how to forward traffic to get to that web server address. Now let me ask you, does that sound scalable to you? And the answer is no, because think about that. You'd need one route here, a route here, excuse me, a route here, and that's just for that one address. What happens when you need to go to another web server at another address? Then you get to come back to this router and this router and this router. And again, it might seem like overkill, but again, I want to drive home the point that this is why individual static routes on all of these routers is not sustainable. And again, we're assuming that these PCs want to have connectivity out to the internet and probably to more devices than simply this web server at this address. Hence, the default gateway comes in, right? Or I'm sorry, the default route comes in, and on the routers, the default gateway or the gateway of last resort. So now it says, configure a default route on router 2. And router 2 is the router on which we would configure the default route because it is the only router in this configuration that has the connectivity here out to the internet. And so Router 2 is going to be originating, advertising to both router 1 and router 3 that, hey, if you don't have a longer, more specific match, if you don't have a match for the network, the destination IPv4 network that you're looking up, send that traffic to me because I know what to do with that traffic. And so there's a couple steps, and really there's only 2 steps we're going to follow here. The first is on router 2, we're going to configure a static route, a default static route. So I'm going to say IP route, and this is where we come in with the quad zeros. And that represents all IPv4 networks. So what this statement really says is my route to get to all IPv4 networks for which I don't have a longer, more specific match in my routing table is that I'm going to send that traffic out the serial 010 interface. Now, you'll notice the activity says that you might get a warning saying that if the interface is not a point-to-point connection, it may impact performance. Now, many years ago, that was a true statement. It's not so true today due to Cisco Express forwarding, but you will see that warning. Now, this is a point-to-point interface. The reason why you might see that if you're using a gigabit Ethernet interface, not a point-to-point interface, but a multi-access interface, maybe this is plugged into a switch before it gets to the provider. If that's the case, for that reason, you might see that, you may see that message. And the reason you may get that is because if it's a multi-access segment, you may need to ARP in order to figure out where am I going for my next hop. And so that's why you could put the next hop IP in there instead of just the interface. With just the interface, it knows the interface to go out, but it needs that next hop information. And so that's where Cisco Express forwarding comes into play. And so again, that's a conversation for another time, but that's the reason you see that message warning you that if it's not a point-to-point connection, you need to be aware that it could impact your performance. So we've configured the default static route on router 2. And basically what it says is, hey, if I don't have a longer, more specific match for traffic that I need to forward, when I look in my routing table and I don't have a route for it, I'm basically just going to shove it right out this interface here, serial 010, and I'm going to send it out to the internet. Well, let's check here. Does that help PC3? Can PC3 ping the destination yet? And the answer is, and the destination being that web server on the internet, the answer is going to be no. Because the traffic comes to router 3. Does router 3 know about the manually configured default static route on router 2? Well, let's say show IP route. And the answer is no. What about over here on router 1? Does router 1 know about that default static route yet? No. What about PC1? Can it get to that web server? And the answer is no. But what about PC2? Can PC2 ping that address? And we might drop the first packet because or request timeout because we're ARPing, right? And we get a response back. And now PC2 works because router 2, which is where PC2's traffic will come as the default gateway, it now knows that when I receive traffic for a route, a destination prefix for which I do not have a longer, more specific match in my routing table, which currently router 2 does not have a longer, more specific match than that default route of quad zeros, I'm going to shove that traffic out my serial 010 interface. If I say do show IP route now, you can see there is my gateway of last resort. And we see it as a statically configured default route, which is using the directly connected serial 010 interface as its outgoing interface. And so for router 2, the problem has been solved. Now, again, we could go around to all three of these routers and put static routes in, default static routes. Router 2s would point to, router 1s would point to router 2. Router 3s would point to router 2. But then the question comes up, well, what happens if that link goes down right there? Then I'd have to come back onto router 3 and configure another static route that says, static default route that says, we'll go to router 1, and hopefully router 1 knows how to get out of the network. Or what I might have done is I might have configured 2 static routes on router 3 and router 1. One that points to router 2 and one that points this way for router 1. One that points here, and I could make them floating statics. So the preferred would have a lower administrative distance than the backup. And if the preferred primary static route were to go down, I would then auto-magically take my backup. But that sounds like a whole lot of configuration work, and we only have 2 routers here. What if you had 5 or 6 routers back here? That is not a scalable solution. Yes, technically, can you get it to work? You certainly can. But this is the difference between a network engineer that maybe knows what they're doing and one who's just kind of muddling their way through the configuration, just trying to come up with something that's going to work. And that latter description of a network engineer just muddling their way through the configuration, throwing static routes everywhere, trying to get it to work, that's not where you want to be. You want to be in the position to understand that with OSPF, all I need to do is originate the default route from the router that has that static default route configured that gets the traffic out to the internet. And then we'll let the service provider take care of the routing for us. And so let's go ahead and make that happen here on router 2. And again, remember, on router 1 and 3, we've already seen, and let me see, do show run section, router OSPF. Let's make sure it's OSPF1. So router OSPF1, and that's the current configuration there for router 2. And all I need to do is come in here and say default information originate, because I'm originating, I'm advertising to the rest of the routers in the OSPF routing domain that, hey, if you have traffic that you don't know how to route, send it to me. So we hit default information originate, or we enter it in, we hit enter. Now let's come over to router 1 and let's see if there's a different result here in the show IP route output, and take a look. The gateway of last resort is now set. Router 1 now knows how to deal with traffic for which it does not have a longer, more specific match in its routing table. And you can see here the OE2. Now, what happens when we originate that default route is the default static route is using the static routing protocol, right? And I know that that sounds a little funny when I say static routing protocol, because you might be scratching your head and saying that that's not a routing protocol, it's just a static route. Well, it's looked at from the OSPF perspective as the static routing protocol. In other words, it's not the OSPF routing protocol from which I'm learning this information. We had a default static route configured on router 2, and when I say default information originate, what's really happening is that default static route is being redistributed from the static routing protocol into OSPF. And OSPF treats routing information that's being redistributed from other non-OSPF routing protocols, and that could be a static route. It could be a directly connected route. It could be an EIGRP route. It could be BGP. It could be IS to IS. It could be RIP-v2. Whatever the case is, if it's not an OSPF route that is being redistributed, and it's not coming from the OSPF routing domain that's being redistributed into OSPF, this is by default how OSPF treats that routing information. And if I go up a little bit further here to our codes, you can see that the OE2 is that it's an external type 2. And that is the default for routing information that's redistributed into OSPF. And that's exactly how OSPF treats that default static route that has been redistributed into OSPF. Now, what is a little different here is the metric in terms of the default OSPF behavior. Because this is a default static route, the metric by default is going to be 1, not what it typically is with other information that is not a default route. Other information would be a metric of 20. Now, the administrative distance is still going to be 110. OSPF doesn't change the administrative distance based off of the fact of whether it's an OE1, an OE2, an OIA. The administrative distance for OSPF is 110. It's the metric or the cost to reach this destination that by default will have a value of 1. For a static default or for a default route. For other information that gets redistributed into OSPF, in other words, all other non-default routes that are redistributed into OSPF, by default the metric will be 20 as an OE2. Now, as you can see, we've got 100%, and that's great, but like I always like to say, it's about more than that 100% in this packet tracer activity. It's about understanding the technology and the different things that we can do here. So what I'm going to do now, and if we were to jump onto, let's validate here, PC1, you'll see that PC1 is going to work. We'll come to PC3, and PC3 is going to work because router 3 also now has a default route, which is an OE2. And so that's what it would show up as. Now we're going to transition over to some real Cisco routers. And I'm going to go to my whiteboard here just briefly to show you that we've got router 1. So I'll just say R1. And it has a serial connection to router 2. And so this is going to be our internet router. And I've put a loopback address on here for the 64.100. I'll just say the 64.x.x.x. So we have a loopback address that's simulating that exact same IP address, the 64.100.1.2, that we're using for that web server. And so here we have a 209 subnet, and I'll show you that information as well. And then router 2 is in fact connected to a switch. And off of this switch, we've got router 3, and we've got router 8. So a little different than what we were just looking at, but again, it's the same exact scenario. So here is my little company network for company A. Here is my service provider over here, router 1. I've got this 209.x.x.x, and we'll take a look at what that actually is in just a second. But when we look at this, the scenario is the same. I may have clients back here off of router 3's LAN segment, and I'm just using over here, I'm using a loopback address to simulate the LAN segment. But these clients, they want to get to the internet. And I don't want to have to put static routing information on all of these routers telling them, hey, here's how you can get to router 2 who has a default static route, and then we can get out to the internet. No. We want to approach this the way we should. We want to leverage and take advantage of the features of the dynamic routing protocol, OSPF. So what we're going to do is we're going to configure a default static route here, and then we're going to originate or advertise. And again, we're redistributing that default static route into OSPF, and then it would be seen here on router 3 as well as on router 8. But we're going to go a little bit deeper. We're going to take a look at what happens when I use the always keyword. What happens when I change the metric value? How would you do that? And I'll even, as a final step, we're going to change the metric type so you can see what that would look like. So let me go back. That drawing will stay there so that we can reference it. But let's come over here and take a look at our service provider router. So I say show IP interface brief, and we'll see there's my 209 on the serial 000 interface. Do I have connectivity over to customer A, right? Or network A. And let's ping 209.165.12. And that would be 2 on that side. And my IP is 1, and I do. And you can see, here's that web server address, 64.100.1.2. And is that actually the same? Let me double check that. 64.100, yes, .1.2. Okay. So, and that's just simulating our web server because we're going to be pinging that. We're going to be trace routing to that. So now let's come over here to router 2. And let's get into privilege exec and then into global config. And let's say do show run section router OSPF. So there's my OSPF configuration right now. Now what I'm going to do is I'm going to go in here and I'm going to say router OSPF1. Oops, sorry, router OSPF1. And we're going to say no default information originate. We're going to pull that out because we don't want that to be seen. So if we come over here to router 3, and router 3 has the 192.168. It's just a loopback, and the loopback is 192. And as you can see here, I'm just simulating if this was a /24 network, and this is the loopback is a /24. Show IP or show run interface loopback 192. And you can see it's a /24. So in the routing table here on router 3, do I see a default route? No, the gateway of last resort is not set. So traffic that showed up here for which router 3 doesn't have a specific match, that traffic is going to get dropped. Let's take a look at router 8. And over here on router 8, we say show IP route, and router 8 does not have a gateway of last resort. And so we're going to remedy that right now. So let me come back over here to router 2. If I said do show IP route on router 2, do we have our default static route here? No, the gateway of last resort is not set. So let's go ahead and fix that first. So I would say IP route, sorry, 0.0.0. And by the way, the zeros are free. You can put in additional zeros and you're not going to see a typo. Now, obviously this isn't recommended. This is just kind of a, hey, so that you know, if you did hit extra zeros, you wouldn't have to backspace when you're using the quad zeros. You wouldn't have to backspace here. It just treats it as 0.0.0.0. And you'll see that right now. So router 2, we're going to say go out that serial 000 interface. Now, you'll notice that I don't get that message. And that's because this router is running a very recent version of Cisco iOS, 15.7 code. And I'm assuming here that this version of code knows that is a point-to-point interface. So it's not going to warn me saying, hey, if that serial interface isn't a point-to-point interface, you may have performance issues, because it knows it's a point-to-point interface. So we don't see that message here. So there's my default static route. Now, what does it look like in the running config? You're not going to see, and I'll say include IP route, you're not going to see all those extra zeros, right? And so you can put them in there if you did it by mistake and you just wanted to keep going, not a problem. But what you're going to see in the running config is the true syntax of IP route quad 0, and my outgoing interface. Could I have put a next hop IP address? Absolutely. I'm just using the interface here. So we now have a default static route. So if I say do show IP route here, you can see that there is my default static route. So now what I'm going to do is I'm going to go into router OSPF1, and I'm going to say default information originate. Now, let's tweak the metric a little bit here. So the default metric is 1, but I can set the metric value to anything in those ranges there. So let's just set it to 500. And let's see what happens. So if I say do show run section router OSPF, what does my OSPF config look like now? And you can see default information originate metric 500. So now if I come over here to router 8 and say show IP route, I should see an OSPF learned default route with a metric of 500. Again, the administrative distance for OSPF is 110. And that is not going to change in this scenario. And it's an OE2, which means it's an external type 2. It's coming from another routing protocol, specifically the static routing protocol into OSPF. So OSPF is going to treat it as external, and by default, it's a type 2, meaning that this value 500 will always be the value, it'll always be the cost for that route because it's an OE2. So let's come back over here to router 2. And let's say no default information originate metric 500. Let's say default, information originate, and let's change the metric type, because remember there's an OE1 and an OE2. And you can see here, what kind of route am I going to be advertising here? An OE1, which is a type is a external type 5, but a type 1 or a type 2. Now the difference when I say metric type 1 is if we come over to router 3, and 8 would show the same thing. I'm just jumping to router 3 here. Is we're going to see an OE1 here because we changed the metric type. And so what's the difference between a type 1 and a type 2? And this is a great little way to show you. So you can see here, the metric here shows 2, but I was just telling you for a type 2, the default is 1. Now, you might be thinking, well, that must be the default for a type 1. And let me restate that to make sure I'm stating that correctly. I told you that the default for the type 2 has a metric or a cost of 1. And if you're looking at this thinking, oh, okay, so then the default for an OE1 has a metric or a cost of 2. And that is not the case, right? So that's not the case. And I'm going to explain that right now. But let's pull this out here. And just to make sure, I always like to demonstrate, and we'll pull the metric type off. So that means by default, we're going to see a type 2. And by default, the cost is 1. Now, the difference here is the type 2, which is what we're looking at right now, sets the cost, and it's set it and forget it. It's going to set the cost on that default, on that default route to 1, and it's always going to be 1. It's never going to increment. If you don't like that behavior and you want the routers to actually take into consideration the actual real cost for these routers, router 3 and 8, to get to router 2, then you would set the metric type to 1, because that is going to add up the intermediate hops that it has to take and calculate and add in those costs along the way. So in other words, OE1 is truly accurately reflecting the cost to get from router 3 to this default route. Whereas an OE2 is set it and forget it. The cost is always going to be 1. And so the reason I wanted to touch on this is, again, this is going a little beyond the CCNA scope, but it's good to know what the difference is between an OE1 and an OE2. The OE2 is set it and forget it. For the default for the default route in OSPF that we've originated, the cost is going to be 1, and it's always going to be 1. If that isn't what you want, if you want it to be a little more accurately reflected, the cost, you would set the metric type to an OE2. Now, the final thing that I'm going to talk about, and this is one that learners always ask about, is what is this default information, default information originate? And if you look here, we've got this always command. What does that mean? Well, let me do this before I set the information, default information originate always. Let's pull back that static route. So we'll say do show run include IP route. So if I remove the default static route and I go into router OSPF1 and I say default information originate, what am I originating? Do I have a default route here on this router? Do show IP route. Is there a default static route here? No, we removed it. It's gone. So when I say default information originate, that is to originate a default route, not to originate anything else. So let's come back down here to router 3. Does router 3 still have some kind of a default route here? No. The gateway of last resort is no longer set. And the reason it's not set is because I didn't configure the default static route on router 2. So when I issue this command, default information originate, like I did here, right, and hit enter, there is no default static route to originate, to redistribute into OSPF, into the OSPF domain, so that all of the other OSPF speaking routers can learn that default route, and then they have a path out of their network. And so that's what this command is for. Default information originate always. Now, there's some caveats here. Remember, I still don't have a default route defined on router 2. If I say do show IP route, that command doesn't magically create a default static route here. What it does do, the always keyword says, even if there's no default static route defined here on this router, I still want you to originate and advertise to the other routers in this OSPF routing domain. I still want you to originate and advertise a default route in OSPF. Now, you might be asking, well, wait a second. What is the traffic going to do? Well, let's see. So from here, can I ping the 64.100.1.2 when it's coming from that 192 network? And again, that's a loopback interface I've got here simulating that network. And the answer is no, it's not going to work. And we get that destination unreachable with the timeout in between there, that we can't reach the network we're trying to get to. What if I was to trace route to the 64.100.1.2 coming from that 192.168.10 network? And you can see trace route gives us an even better message here. We see this exclamation mark H, and that means host unreachable. And same thing, this is destination unreachable. This is saying, hey, I can get over here to router 2, but in router 2 being kind of like our gateway router for this environment, if we go back and take a quick peek here, right? Router 2 is my gateway to get out of our network to the internet. And what's coming back is a notification telling me, hey, I can get there, and I get there in 0 milliseconds. That's how quickly the round trip is. But I'm getting this message, right, coming back as a response telling me, hey, that host is I can't get to that address that you're trying to get to. And again, the reason is that yes, we have the default route in the routing table. We see that in show IP route, and I'll trim it down just to show IP route OSPF. You can see the default route is there, and router 2 is the router advertising it, and that's the interface out which I go to get there. The problem is when the traffic gets there, router 2 has no default route. Now, you might be asking yourself, okay, well, why would you use always? And here's one, I'm going to give you 2 use cases, right? Because again, this is always the key with these different keywords or these different options that you can set. It's like, well, when would I do that? Why would I want to do that? Well, let's say that you have a static route configured to get to the 64.100.1.2 because you want full control over the routing. Oops, sorry. You want full control over the routing on this router. You only want to allow traffic to transit to the internet that you are providing routes for, individual routes. And again, the always, I've seen it come into play more often internally in networks, not so much with the route out to the internet. Because if that interface to the internet goes down, right, then you're not getting to the internet. So the always keyword is really not going to give you much value add in a scenario like that. But in an internal network, you might use the always keyword to drag traffic to a specific router that does have individual routes on where it's trying to go. So now that I've put this route in here, let's come back. Sorry, let me come back down. Let's come back to router 3 now, and let's see what happens, excuse me, when I try to ping. Because now the traffic gets to router 2, and router 2 says, okay, I don't have a default static route, but guess what? I have a static route to get to that 64.100.1.2 network. So this is going to work. What about the trace route? What does that look like? Well, if we can ping, we can certainly get there. And again, the end of the road for me is router 1, which is that 12.1, and router 1 responds back and says, yeah, that network is here. So that's one use case. Again, that always keyword, I've seen it used more in internal scenarios where you're controlling the internal routing. So now let's go ahead and let's remove that individual static route. That is not a default route. Remember that. That is an individual static route. So what might we also, or how could we also use that default information originate always keyword? And here is the use case for that. So if I was to say, let's put back in this default static route and send it out serial 0/0/0, right? So my default static route is now back in there. So we've got the always keyword there. So if I say show IP route, you can see that it's being advertised. And here is another scenario in which you may want to use that always keyword. If you have any kind of IPS or IDS sensors on your network that are trying to see if traffic is trying to go somewhere for which you don't have a specific route. And again, it's more of an internal use case. And let me go ahead and excuse me, draw this real quickly. So internally in my network here, if I've got a host out here who, for whatever reason, maybe they're trying to go to a blacklisted website, or maybe we've got malware that has been installed on this host by the user of this host. Who knows what the case may be? And then that traffic is trying to dial home and get out to the internet, right? To maybe make a connection through our firewall so that more malware can be installed, whatever the case may be. I might want to see that traffic. And I might want to see it even when the interface here, out which that default static route points, has gone down. And so this is what that might look like. Let me go ahead and get control of the screen back here. And hold on one second. There we go. And so this is what that might look like, because if I've put the static route there, if I don't have the always keyword and I go to interface serial 0/0/0 and I say shut, and I shut that interface down, without the always keyword, the advertisement of the static default route goes away. And I'm going to show you that right now. Let's go into router OSPF1. I'm going to say no default information originate always. I'm simply going to say default information originate. So you might be thinking, oh, well, you have the static default route and you're saying default information originate. True, but remember, the interface out which that default static route points is down right now. So when I come over to router 3, is router 2 going to advertise? And here's your question. Is router 2 going to advertise and allow that default static route to be advertised into OSPF, knowing that it's going to black hole and drop that traffic because the outbound interface that it needs to get out for that default static route is gone? And the answer is no. And so again, router 3 and router 8 are left with no default route, no gateway of last resort. But again, if we want to continue to drag traffic up to this router so that and again, we may have sensors, span ports that are gathering traffic on that switch in this setup. And I want to see, hey, do we have any traffic coming off of the LAN segment here for router 3, right? And you can see what the always keyword did. It's going to advertise that default static route irrespective of the fact that the interface on router 2 that route needs to get out is down. And the reason for that might be that I have a device here that hangs off here, and maybe I'm spanning these ports right here, and I'm watching with my and I'll just put XS, IDS, IPS, my little device right here, and I'm getting copies of all of the packets that are flowing from router 3 and router 8 to router 2. This is an instance where I may want that, right? Because again, forensics, accounting, whatever the case may be, that's going to ensure that instead of the traffic, the bad traffic, coming to router 3 and then router 3 saying, I have no clue how to get there, and notifying you, the bad traffic is going to show up to router 3, and router 3 is going to say, oh yeah, well, I have this default route that I learned in OSPF, and it's going to send it through that switch so that we can capture it, and then it's going to forward it out. All right, well, I think that we have exhausted all of the propagation of a default route into OSPF2 options that we looked at. And again, to recap, you create the default static route on your gateway router, and then you can use the default information originate command. And if that static route interface goes down or the static route goes down or gets removed, then that static route gets pulled. Use the always keyword if you want it to continue to be advertised for those forensic purposes we just talked about. We looked at the metric, right? Very important. The default metric for that static route that gets redistributed into OSPF and originated into OSPF is going to be 1. The administrative distance will stay 110. Unless we change the metric value, like I showed you how to do, or we change the metric type. Remember, the difference between the OE1 and the OE2 is that the OE2 is set it and forget it. On that static route, on that default route, the metric is going to be 1, and it's always going to be 1. Even if you were 85 hops away to get to it, it's still going to show as a 1. Now, if you don't want that, if you want the real true cost to get there from inside your network, change your metric type to 1, OE1, because the OE1 does care. And it is going to take into consideration all of the intermediate hops and the costs of those hops to get from your source to that default route location. All right, well, that is going to do it for this packet tracer tutorial. Again, wanted to make sure we're very comprehensive and we went over everything we possibly could, and that is it. Have a happy holidays. Thank you so much for watching, and I hope I have earned the privilege of your time. All right, have a good one, and I hope to see you in the next video.